Okay, we are done with spring break. This is Monday, and hopefully everybody had a nice spring break. Everything's online because of the virus. NET, Introduction Network, talked about. The students did some lab work, routing topics, and then some more lab work. Let's take a look briefly what I had on the board. This is a review slide. Okay, so this is from before spring break. We divided up into groups, assigned routers. We actually have a group 6 now with some assigned routers. And what the students did initially was get a switch onto the router and get it configured so they could access the router from the switch. And they could have a PC here, and they could telnet, okay, before spring break. So what we have a switch we used to have. This is the previous setup, a switch connected to a multi-layered switch. In fact, everybody had their own switch at that point. That connects to a router. This is device 24, which then connects to the DMZ, which then connects out to the firewall, and then the firewall eventually is connected to the internet. So what we've done is we've added a router in between here. So these devices, so we're going to create 2 more networks. We have the network where the router is connected to, then the router. This is another example here that we talked about, like a WAN connection. But this would be a network too. So we had addresses like this, and then we said if we were going to take this address and we need to split it into more networks, we could take the host or interface part, and we could take those 8 bits and we could divide them up and make this the host and interface part and this the network part. We talk about that next week. So here's a better picture of our scenario. You have your layer 2 switch connected to the router, okay, and we have, how many routers? 11, I think, in our scenario, and each group has like 2 routers. Okay, so then this was the network part. We happen to use the same addressing, and this is the host or interface part. And we know it's the network part because we have 24 prefix bits. If you were going to write the mask for that, that would be 255, that's 8, 255, that's another 8, and 255, that's another 8 bits, -0. So that's how we get 24 bits. You will see the prefix mask be used more and more instead of writing the mask out this way. Now, a key part to making this work is you have to configure this interface, and all of this has to be on the same network. Okay? In our example, this network right here. So you have to organize your addresses. Then you can put in a default route pointing to the interface going out. So this is the fast Ethernet 00 right here, and this is the next hop. That next hop there, that's the address up here in the multi-layered switch. So if I was to use another color to show those, this is this interface, and this is this interface. And they're all on this network. I used a /24, be the same as down here. We will talk about changing that next week. We'll start talking about that. So then the multi-layered switch is connected to device 24, which is connected to the DMZ, which is connected to the firewall, and the firewall is eventually connected out to the internet. So our goal is to understand communicating between networks. And then you have these addresses here too that are key for testing. Okay, that .1 there. Let me use another color. Use blue. That .1 there, .2 there. There's a .1 there, a .2 there, and then this address is at the firewall. You'll be able to ping that address on the edge of the firewall, but you will not be able to telnet to it. But you should, if your network's working, you should be able to telnet to all these devices. And then also, right, we have 6 routers connected. No, 11 routers connected, and so you should be able to connect to all those. And you have the addressing is in the lab. This was from at home, so I ran through a laundry list of items. Okay, let me highlight those. So this was Wednesday. I wonder if I should use a different color. I'll use black. So yeah, this was Wednesday. First of all, packet tracer, I said, now make sure you ask questions, and I still have to create the solution file. So I will do that here in the next couple days. Alright, so Zoom, I'll have Zoom on during office hours if you want to check in, or you can set up a Zoom session by appointment. Just contact me either text or email and we'll set it up. Looking forward, next week is IP4, then IP6. Some of you said we're having issues trying to distinguish, the difference, and IP6 is a little more confusing. But once we get a good understanding of IP4, 6 will be much easier to understand. Then I did some general talking about routing. We talked about time to live and hop count. So when a packet moves through the internet, here I could probably use a brighter color. Let's use red. So on a packet, these are hops between routers. So if a packet is wandering, eventually when the hop count gets to 0, then the packet is dropped, put in a big bucket or thrown away or whatever. Because obviously if it hasn't gotten to where it's supposed to go, it's lost. That's a funny way to say it, but so you think about all the steps that it takes to move from your PC out to your website, and then from your website back to your PC. So during that transition, packets can get fragmented and then put back together, and it creates what they would call latency, because everything's done by timing. So it creates a certain amount of latency, which then can cause jitter, which means items are not arriving at the exact time they should be, so they have to kind of reorganize it to intermediate devices before they resend it. So you get a little bit of latency. Okay. Now, through this mess, we'll see if I can summarize a couple other things. If you remember, we from our routers, we created these default routes going out. So if the router can't find a network connected to it, connected networks, like our networks here are connected, if it can't find those, Then it says, well, I'm going to send it up to the next router. Now, if this router can't find it, it defaults to here. If this one can't find it, it defaults it to here. And so you can see once it hits the firewall, let me put that here, once it hits the firewall, and then the firewall will decide, does it belong in one of the other networks here in our area, or send it towards the internet. We have the regular network that our PCs are connected to, and we actually have a DMZ2, which we have some equipment connected to, mostly for testing right now. Okay, I talked briefly about how when you log in the work server 2, then you type in this address, which is the address on this router, and that router then has those 32 connections that allows us to console into our equipment. Kind of looks like the sun coming up there. Okay. Alright, and then the same thing we talked about, we put a default route in the switch so that if somebody over here, let me use green, somebody over here, if they telnet to your switch, that switch has to be able to, since their address is not on your network, that switch says, well, where is that address? Well, it doesn't remember where everybody is, but it does know, well, if I don't know where that address is, I just default to here. This device doesn't know, it defaults to here. Now this routing in here, it has routes to all 11 networks that we are using. So one thing you can do is if you telnet into the multi-layered switch, you can do a show IP route, and you'll see all those routes. And if you do a show run, you'll see a bunch of stuff you don't need to worry about. There's stuff in there that we used for doing other type of networks, but if you do a show run, eventually you'll see the static routes pointing back to everybody's network actually typed in. Finally, let's finish up here. So we showed that from your switch you should be able to ping all the way to our network here. Now when you look inside device 24, there's network address translation. So all of the addresses on this side, I'm going to use red here, all of the addresses on this side all have a 192.168. Let's highlight that again. So this router has a route that says if it's going, here, it's going to send it down here. If it doesn't know, it's going to send it this way with the default route. What NAT's going to do is it's going to convert these addresses to addresses on this network. We learn more specifics later. So when it hits this switch, it's on this network. So you can translate, you can do a network address translation. You can say, and that happens every time you do this. When you ping, as soon as it hit here, it converts it to an address and matches it up with a port number to keep track of it, and then when this firewall sends it back, it gets translated back here, and then it goes to the correct device. We will review that on Monday. That'll be a good thing to review. Okay? So again, then there's IP addresses assigned here to this port, but up here this is just a switch, so it just moves it straight to the firewall. This switch is also doing DHCP, so when we looked at this address, we could see that instead of us configuring it, the DHCP server gave us an address there. That's enough for this week. Make sure you communicate with me if and when you have questions or something isn't working right and so forth.